As I mentioned in the last video, there's a lot of problems that we're going to see that multiply binomials type binomials, and sometimes there are some special patterns that emerge that can let you take a shortcut. So I want us to use the FOIL method to multiply x plus 4 times x minus 4, and then also 2b squared minus 9 and 2b squared plus 9, to see if we see any pattern that happens when our terms are the same. We have an x and a 4 in both binomials, or a 2b squared and a 9 in both, but the operations change. This is positive and this is negative. So let's see what happens. We have x times x gives us x squared. Our outers will give us a negative 4x, the inners a positive 4x, and the last a negative 16. When we do this one, we get 4b to the 4th plus 18b squared minus 18b squared minus 81. Then we combine those center terms, and look what happens in both cases. These center terms, minus 4x plus 4x, or minus 18 or plus 18b squared minus 18b squared, end up canceling each other out. So we're left with just x squared minus 16 and 4b to the 4th minus 81. And that pattern will be true anytime you multiply a binomial where the terms are the same but the operation between them is addition in one and subtraction in the other. So the shortcut rule that we can write is that what happens, the middle terms cancel out, every time. So if you see one of these special cases where the terms match but the signs differ, you can take this shortcut. Multiply the first terms, multiply the last terms, and then because this positive times a negative is always going to end up being a negative, you're always going to see that the final answer ends up being the first term squared minus the second term squared. First term squared minus second term squared. So that's our shortcut. So if we practice a couple of examples using this shortcut, we're just going to get 10 times 10, which is 100, minus a times a, which is a squared. Here, 2/5 x times 2/5 x is going to give us 4 25 x squared minus y squared.